Welcome to today's American Trainco conference call titled A Preview of the 2014 National Electric Code. During the presentation, all lines will be in listen-only mode. Attendees may submit questions at any point during the presentation by selecting Submit a Question in the lower right-hand side of the screen. These questions will be addressed at the end of today's presentation. Today's speaker is Bob Clukey. Bob brings over 35 years of practical electrical experience to his students in every class he teaches. Bob has been with American Trainco since 2007, and in that time he has become one of the finest instructors we've ever had. Not only is Bob a licensed master electrician, but he is also a certified NCCER and OSHA instructor. In addition, he is a member of the National Fire Protection Association, NFPA, and the International Association of Electrical Inspectors. Thank you for your attention. I would now like to turn the conference over to your speaker, Mr. Bob Clukey.
I want to welcome everybody this fine morning, and hopefully we will address some of your needs in the new 2014 National Electrical Code. And you can see that there's my bio a little bit. I do have about 40 years experience in the electrical trade as an outside contractor and licensed master electrician in a couple states. So want to give you a little bit of idea what we're going to be talking about today. We are going to go through some of the major changes, but of course with 920 pages in this new 2014 National Electrical Code, we might not get to every single change, I would imagine, but we're going to talk about some of the things that might impact people out in the industry, that's for sure. Towards the end, we will answer any of your questions, so feel free to email those, and I will have those in front of me, and we will take about 30 minutes towards the end to address certainly those questions, and also give you a little bit of idea how American Trainco works as we get near the end of the presentation. So, beginning, 3,745 proposals. I want to encourage people to become part of this process. Very easy. You can get on NFPA's website. They do now have a submittal form for any type of concern that you might have. You can also make public comments to this. So we have about a 1 year from this date to get our proposals in for the next code cycle. So if there's something that you see that jumps right out to you and is a major concern of yours, then certainly become part of that process. That's very important, I believe, to make this document as safe as it possibly can be. Some of the code-wide changes, we see that there is going to be in 110.21b, which we will see a slide a little bit later, some specific requirements for warning labels, and this applies to all warning labels. And it's more in line with an ANSI standard, Z535. So we'll be looking at that, and also there is a provision here now for lockable disconnecting means. So this is brand new in the 2014 code, and what they did is they went through about 46 sections in this code that required lockable disconnecting means in various articles, and they felt with that many sections in the code that required that, it was time to put that in the general requirements up here in Article 110. And if there is a section that does require that, then we're going to see it in that particular section. And I quickly scan the code to see how many articles that might affect, and it affects about 20 articles that will refer us back to 110.25. I do also want to mention that in that section that lockable disconnecting means it does have to remain in place with or without the lock installed. So what's that going to do for us? We're going to have some hardware on our panels. We're going to have hardware on our disconnects that we'll be able to put a lock on there and not have to worry about maybe locking out a circuit breaker anymore, because there's going to be a hard fixed piece of metal there that our lock will go on, and the circuit breaker just will not be able to be turned on. So, the days when we had to use that little red adapter and get it on the breaker, those are going to be over, because all new equipment will have this device that is going to remain in place with or without that lock installed. Also, we can see that at the bottom of the slide, the last bullet, that there has been some changes throughout this National Electrical Code on DC systems. And I was going to say these are very important changes and a lot of changes. So I'm going to address a few of these right now as we speak, especially some in the Article 690, the photovoltaic article that we have. They gave us a couple new definitions in there, one of which is a DC to DC converter, and it actually allows us to bring in a DC power source, and then we can change that. We can make it a higher or lower value than what was inputted into this converter. So electronically, they are giving us a chance to go ahead and get a power source coming in, and then going out, we can change that to whatever we need. Another new definition that they put in photovoltaic systems is a combiner. So it's a DC combiner, and it is used to allow two or more DC inputs, and then it provides us with one DC output. So that's going to be very important to the photovoltaic industry. Also, in 690.5, they have required now that there's going to be ground fault protection on these photovoltaic arrays. And they've given us a list here of what that system is going to have to be able to do. Most of this will be provided to us by the manufacturer, but it does have to be capable of detecting a ground fault in the array itself, also the conductors and components. So it's got to have that capability of making the detection of a ground fault. And we're also going to see that it's going to have to interrupt that flow of current once it makes its detection. It's going to have to provide an indication of the fault, so we'll see some type of light or something come on, and it has to be listed to be able to protect photovoltaic systems. Continuing and staying with photovoltaics, because there was some major changes in this article. In 690.12, they have a requirement now that we have to be able to shut down these photovoltaic systems within 10 seconds. And the biggest reason for this is because fire personnel might come to a building. There's two power sources, the utility and the photovoltaic system. And the photovoltaic system is usually, in the past, is always going to be energized. So now they've given us this requirement that for all the conductors that are associated with that photovoltaic system, if they are 5 feet in length inside a building or more than 5 feet, then those are going to have to be able to be shut down within 10 seconds. Also, all the voltage and power that's measured between these conductors and ground will have to come down. It's going to have to be a label on there that identifies this shutdown equipment. So very important that we understand that some DC circuits here are definitely being affected by this 2014 code. Next slide gets us into definitions a little bit. In Article 100, we'll see that there has been a lot of definitions relocated. For familiar users of the code book, you would notice that in the left-hand margin, there is normally a bullet when we would see a deletion. So one of the ones that we might see, if we went to Article 430, we would see a bullet in 430.2. Dot 2 is, of course, definitions pertaining just to motor circuits. And one of those definitions that were deleted actually got relocated into Article 100, and they changed the title of it a little bit. It was motor control circuit, and now it has only been defined as control circuit. So it can be applied to every article in the code. It's basically a circuit that carries electric signals, and it's going to direct the performance of the controller, doesn't carry the main power. So that was one of the definitions that got relocated into Article 100. Of course, for a definition to be included in Article 100, it has to appear in 2 or more code articles. Another definition we can see, switchgear. So in the 2011 version of the National Electrical Code, we saw metal enclosed power switchgear. So that was changed a little bit and simply titled switchgear. So I mean, if we searched the 920 pages, we see that's impact in a lot of articles, and switchgear will appear there for us now over and over and over again, and it's a nice little change for us. So that definitely is going to be in there. Another definition that got put in Article 100 under selective coordination. It is going to have to be performed by a licensed professional engineer, which most of the time in the past that was always the case, and he is going to have to make sure that he has either a calculated system or a tested system. So, and he's going to have to provide documentation to the authority having jurisdiction on how he determined that it was coordinated. So, very important to understand that got put into Article 100. Also, the definition for raceway got changed a little bit, and this definition is in Article 100, but there's an informational note that was added to it, that if we have a specific raceway, we're going to have to look in Dot 2 of that specific article. So if I use, for an example, Article 344, rigid metal conduit, if we go to Dot 2, we would see that specific definition there for that particular raceway. So in Chapter 3, where all of our wiring methods are, we definitely going to have to take a look at Dot 2 to see some of those definitions. And we should understand about Chapter 3, how it is laid out a little bit, that Dot 1 is always the scope, Dot 2 will always be definitions, Dot 10, where we can use that particular wiring method, Dot 12, where we can't use it, Dot 30, how to secure it and support it. So Chapter 3 is laid out pretty good for us there. At the bottom, you can see we do have 4 new articles added to this 2014 National Electrical Code, so we are going to take a look at those in a minute. Also, we have the 600 volt has been raised to 1,000 volts, and many changes on that in the code book. They did assign a high voltage task group, so the code making panels had a committee to go ahead and take a look at raising that up to 1,000 volts, and the reasoning for that is there are many systems that are currently out there between 600 and 1,000 volts that in reality they're still fairly safe, and I want to give you a couple examples of that. New York City subway, 625 volts DC. The MARTA system in Atlanta, Georgia, 750 volts DC. So it was becoming just more and more common, and the task group had a hard time as they went back through the history of the National Electrical Code. They couldn't really determine why it was ever the 600 volt threshold was there in the first place. So they felt that it would be very wise to raise that to 1,000 volts so that people could work on that, and we could put some requirements in the National Electrical Code that would help with safety just a little bit. Before we do leave this slide and get to the new articles, I would like to mention one more definition, readily accessible. They have changed that up. So historically, readily accessible has been we can walk right up to it, put our hand on it. We don't need any ladders. We don't have to move any ceiling tiles. And so what they have added here is that we also don't have to use any tools. So if we need to use a tool to access something, it is not going to be readily accessible. It would still be accessible. We could still get to it, but it would not be readily accessible. So important that we do understand that. Now for our 4 new articles. Okay. Very first article titled Low Voltage Suspended Ceiling Power Distribution Systems. It is in Chapter 3, so this is a wiring method. And this gives us another opportunity to go ahead and, mostly this is going to be for lighting, but the ceiling grid itself will be the conductor. So I want to give you an idea that what this is going to be and the voltage range it's going to be in. These are low voltage suspended ceiling distribution systems. They are going to operate right around 30 volts AC or less, or 60 volts DC or less. The one that I've seen so far was 24 volts DC. It has to be listed as a complete system. It's going to come with its own utilization equipment, so the lights that are going to be mounted to this ceiling grid will come with it. The power supply will come with it. All the fittings, everything will be identified as a low voltage suspended ceiling power distribution system, and it's very similar to track lighting. So our lights will come up and we'll turn and they'll snap onto that grid, and it's going to be very handy, especially with LEDs. It should be a nice little addition for us as far as another wiring method goes. It will come with a listed Class 2 power supply, so it's going to be a very low energy power supply, and all the rails will be listed. All the low voltage cables will be in accordance with Article 725, which is our Class 2 and Class 3 power supplies. I want to give you an idea. I've already told you that Chapter 3 is laid out a little bit, and Dot 10 is where we can use it. So I want to give you an idea where we can use this new wiring method. We can use it indoors in dry locations. It can be in residential, commercial, or industrial installations. We can actually use it in a plenum as long as it has adequate fire resistant and low smoking producing characteristics. So we'd have to look at the listing for that, but some of this wiring method will be allowed to be used in a plenum. Where we can't use it is going to be in damp or wet locations. Definitely will not be able to use it in storage battery rooms where there's some corrosive fumes or vapors. Can't use it if it's going to be subject to physical damage. We can't conceal it. Cannot be used in hazardous locations, so Class 1, Class 2, and Class 3 are out. And can't use it if it's part of a fire-rated ceiling, so it couldn't be used there. Also cannot be used up in Article 517, so it's not going to be used in hospitals. But definitely in our residential and commercial industrial applications, other than those I just mentioned, this should become very handy for us. The next article we see, modular data centers. So for a long time in the code we've had Article 645, IT equipment, but it really didn't address when the data center was built off-site and then delivered as one unit. So this is a prefabricated unit. It is 600 volts or less. It's going to have an outer housing, of course, and inside it will have its racks and cabinets, servers, UPS systems. It will come with its own air conditioning system, so it's a one-shot deal, and it will show up completely wired and ready to go, and all we have to do is supply power to it. So the National Electrical Code wanted to address this to catch up on technology a little bit. In Chapter 7, we also have two new articles, fire-resistive cables. So I'll give you the definition of that. It's a cable used to guarantee the survivability of critical circuits. So if we were wiring emergency circuits in a hospital, we would want to go ahead and get some of this. Maybe if we were wiring some circuits in the critical operation power system buildings where, some very important data centers or buildings that are vital to the security of our country, we would certainly want to put in this new fire-resistive cable that they've come up with. And the last new article, Article 750, Energy Management Systems, and this is just a system consisting of a monitor, communications equipment, and it's going to control loads or power production, whatever we might need. And these systems have been out there for a while, and so now the National Electrical Code is going to address those, and we'll take a look at Article 750 to be able to determine what we might have to do for those. So 4 new articles. Get back to definitions just for a second, because I definitely wanted to include this one. They gave us a definition for retrofit kit, and it is going to apply to LED listed retrofit kits. And in my experience, what we can do now, any luminaire that we might have in industry, doesn't matter if it's a 2x4 drop-in fixture in a suspended ceiling, doesn't matter if it's a 400-watt metal halide, we can convert that to LEDs quickly. The manufacturers have come up with this retrofit kit that makes it extremely quick and very economical to go ahead and retrofit any fixture that we have out there that might have to, let's say, be a little bit more energy efficient. So that was also in there. That brings us up to 110.16, and this is the requirement in the National Electrical Code for the arc flash warning label. And we can see, I highlighted in gray a little bit, that now that label, it can be field or factory marked. So our manufacturers can put a generic label on that equipment. Most of them have already been doing it. And this requirement still only requires the generic label. And in the next slide, I'll give you an idea exactly what that's going to be. But it does say that the marking has to meet the requirements in 110.21b. So that's going to be very similar to the ANSI 535 standard. And a specific word is going to be associated with a color, and they are going to tell us exactly what might happen to us in that case. So we're going to take a look at that, but we can see this has not changed all that much. So in reality, this is still the generic warning label, warning arc flash hazard. Appropriate PPE required is basically the label that we're talking about here. The wording on the label hasn't changed much as far as the National Electrical Code is concerned. So here we can see the label, and so this label actually is addressing two NFPA documents, NFPA 70, the National Electrical Code. So the top of the label, the warning, arc flash, and shock hazard appropriate PPE required, that's what 110.16 requires at the time of installation, because the National Electrical Code, of course, is an installation guide. So to get our installation approved by the authority having jurisdiction, we would definitely need the top part of this label. Now, the bottom part of the label is required by NFPA 70E, so that's a little bit more specific, and that would involve an arc flash analysis, and we would have to calculate the incident energy. But the bottom part of the label is what 70E requires, but the top part of the label is what the National Electrical Code requires. So we would have to put that on at the time of installation, and as soon as the installation was complete and the certificate of occupancy was issued, we would want to go ahead and get that analysis done and get the rest of that information put on as quickly as we could. And that is more of a work practice. The bottom part, it is going to protect our workers and give them an idea of what they have to wear and the voltage present and how much energy is available. So that brings us to 110.21b. So want to actually take a look at this, because it is going to be a one-stop requirement for these warning labels, and it is going to align with ANSI Z535 like I mentioned before, but it should give us at least some consistent guidelines, because I've seen labels out in industry that might be the color green. I've seen labels that might not have the correct information on them. So we'll take a look and see exactly a little bit of an example of this. If we have the color red associated with the word danger, then that is going to result in death or serious injury. So many times I've seen labels and it might say danger, but it's not the color red. So ANSI Z535 has associated these words with certain colors for a long time now, and now the National Electrical Code wants to also be consistent in what they're going to display on a label. So orange, we can see it is going to be associated with the word warning. It could result in death. And caution, of course, yellow, and it may result in minor or moderate injury. So this does not change the information on the label. This just provides us with some conformity on colors and words, because I have seen, like I said before, arc flash warning labels. They are all over the spectrum, and there wasn't much guidance out there for us, and now we're going to be able to get at least some consistency in color and words, and hopefully we combine NFPA 70E with 70, and we come up with a nice looking warning label, and we make that look professional and protect our workers out there. This is a change. It is in the general requirements of Article 110 for dedicated equipment space, and so most of us forever have known that indoors and in front of our equipment, there's 3 conditions that are present there, and we might have to have 3 feet or 3.5 or 4 feet depending on the condition that we're facing. So now this has been expanded to outdoors, and I don't know, how many of you might be contractors or associated with putting in services, but the service entrance outdoors sometimes can get a little messy with these other systems. So I've seen everybody wants to come near our service entrance, whether it's the gas piping or all the communication equipment or whatever it might be. So what does that mean? We've got to now understand that outdoors is all of ours. In this picture you can see the gutter coming down. Well, we have 6 feet above that equipment dedicated just to electrical equipment. So even the gutter people are going to be associated by this, affected by this. People that bring in other utilities, so water, gas, whatever it is, they've got to stay at least, in this instance here, would be 3 feet in front of that equipment. They're not going to be able to get that close. So everything outdoors now definitely is going to be affected by that. So that's going to be a little bit of a major change, and we're going to have to make sure that in the excavation process that people aren't putting pipes in front of our electrical equipment, because very important that we take care of that. 210.5 C2, as I said earlier when I introduced the whole webinar, DC systems have been affected a lot in this edition of the National Electrical Code. So they have finally given us a color code, which it's the same color code we've used for most of our life. Red is going to be for the positive conductor, and black is going to be for the negative conductors, and you can see that's for size 6 and smaller. Once we get above number 6, then we can identify it in different ways now. We can use wire markers, tags, any approved means that the authority having jurisdiction would go ahead and accept. But number 6 and below, it has to be continuous red or continuous black, and above that though, there's we can get some positive or negative signs, however we want to maybe mark it if we get above 6. So some new requirements there for DC color codes. Now we get to GFCIs. So in the 2011 edition of the NEC, it told us that all GFCIs had to be readily accessible, so we had to be able to walk right up and be able to test it. The testing requirement from UL is that GFCIs are tested monthly, so the readily accessible requirement would be very important. We can see now that they deleted a phrase under dwelling unit sinks, which used to say in 2011, including kitchen sinks. Well, now what that means with that phrase being deleted, that every receptacle within 6 feet of a kitchen sink is going to have to be GFCI protected. How is that going to impact us? Well, if you're like me and you like to put the garbage disposal on a cord and plug, so that it's very easily removed, rather than having to lay on our back and disconnect the hard wire. If we have it on a cord and plug, there's going to be a receptacle, and it's going to be right below that kitchen sink. That is now going to have to be required to be protected by a GFCI. If the refrigerator is within 6 feet of that kitchen sink, we are now going to have to put a GFCI protected receptacle for that refrigerator. And it's going to have to be readily accessible. So we're not going to be able to put a duplex GFCI behind that refrigerator. We're either going to have to protect it with another GFCI, or if we want our refrigerator to be on a dedicated circuit, it looks like we're going to be getting a circuit breaker GFCI. So some major impacts. You can also see that if your kitchen sink is on the same wall as another room, whether it be the dining room or the living room or whatever it might be, and there's a receptacle right on the back side of that wall where the kitchen sink is, that one is also going to have to be GFCI protected. So some changes in residential GFCIs, that's for sure. And they're going to impact us a little bit. The manufacturer of our appliances are making the motors double insulated, so hopefully it's going to take care of any nuisance tripping. On January 1st, 2008, UL did increase the trip level for GFCIs. They eliminated the 4 and 5 milliamp range, and now the GFCI is going to trip at 6 milliamps or above. So with the new UL standard, and also with the manufacturers making the motors double insulated, hopefully we're not going to have much nuisance tripping on these GFCIs, because like you, I grew up at the time when GFCIs did have a lot of nuisance tripping, and with that refrigerator being on the GFI, I get a little concerned, but I'm hoping that the manufacturers have taken care of us on that. Also, in Part D of this, the dishwasher now has to be on GFCIs, and that doesn't matter where the dishwasher is located. It can be 20 feet away from the kitchen sink. Wherever you put the dishwasher, it is going to have to be GFCI protected. So it doesn't matter if you hardwire the dishwasher or you put it on a cord and plug like I like doing, but this is definitely going to be, we can see that these dishwashers do have end of life, and when they do fail, there is an increased risk of shock, so GFCIs should become very important. GFCIs first introduced into the National Electrical Code in 1971. We had approximately 625 electrocutions every year prior to that. Since we have increased the presence of GFCIs, both in dwelling units and in commercial and industrial buildings, those electrocutions have dropped to about 105 per year. So they definitely have an impact on safety, and we just want to make sure that they're going to be reliable, and we think, you know, with the changes that were made, this should be a great little addition here. 210.12. So now we are in some AFCIs, arc fault circuit interrupters, and this section was completely redone. So we can see that AFCIs now also have to be readily accessible, and this is mostly a residential requirement with AFCIs. So where this has been completely redone here, we'll take a little bit of a look at this, because first of all, what they've done is they've expanded the rooms. So all of the 120 volt single phase 15 and 20 amp circuits in our residential buildings that supply outlets or devices. So or devices has been changed. That means that if we have another circuit in the bedroom, maybe we have a switch in that bedroom to control a fountain outside or some outside lights, and that switch is not part of that bedroom circuit, that switch will now have to be AFCI protected. So outlets or devices in the following rooms, and they've added kitchens. So kitchens now will have to have arc fault circuit interrupter protection. And they always had family rooms, and they always had dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways. All those rooms were in the 2011 version of the National Electrical Code. But they did add kitchens, and they also added laundry areas. So our washing machine will also be part of this AFCI protection. And of course, an AFCI is going to be a listed combination type AFCI that can protect against series arcs that are right in series with the black wire or in series with the white wire, and also parallel arcs that might go between the black and the white. So we're going to have to install these, and they have now given us 6 choices to be able to provide this AFCI protection in a dwelling. In 2011, we had 3 choices, and the number 1 choice was one that we did have in 2011. We can go ahead and get a listed combination type arc fault circuit interrupter circuit breaker. We can install it in the panel, and it will protect that whole branch circuit from any arcs we might see. We also had choices 5 and 6 were also in the 2011 code. So if I used a metallic wiring method from the panel to the first receptacle, if I used rigid or intermediate electrical metallic tubing, metal clad, armored cable, then I could put my regular circuit breaker in the panel, and I could install an outlet branch circuit type device. For you that are very familiar with the 2011 National Electrical Code, you know that those outlet branch circuit devices were not available at the time. UL was still testing those and getting ready to release those. They currently have been released, so we can use them now. And so if I have a metallic wiring method, I can put the receptacle, that is an outlet branch circuit AFCI, at that first receptacle in my circuit, and they feel that the metallic wiring method is going to protect that portion of the circuit from any arcs. And once we get to the first receptacle, then that AFCI outlet branch circuit type device will protect the rest of it. Number 6 was also available to us in 2011, where we could use PVC, type MC cable, as long as it was listed to be embedded in concrete, at least 2 inches of concrete. We could do the same thing. We could take PVC, cover it with 2 inches of concrete, and then we could go ahead and put that first receptacle, making that an outlet branch circuit device. So those 3 choices were all available to us in 2011. Now in 2014, 2, 3, and 4 are brand new, and what they're talking about is a listed branch circuit type AFCI installed at the origin of the branch circuit in combination with an outlet branch circuit device, receptacle. And basically, we're going to see 2, 3, and 4 are going to be very similar. What UL did, they looked at the time curves of most of our modern day circuit breakers, and they felt if that time curve, if it allowed for the instantaneous trip portion to be close to 300 amps, then we can install a common day circuit breaker, and as long as the distance that we were going was relatively short, 50 feet for 14 and 70 feet for 12 gauge, then we could put that circuit breaker in the panel, and then we could protect the rest of that circuit with an outlet branch circuit device. So 2, 3, and 4 are very new. They do have some length requirements on them, and those length requirements are going to be involved with the impedance of the circuit. That's why we have to stay fairly short. If the impedance gets too high, then our instantaneous trip, the current would not get up near that 300 amps, and then the 2 devices in conjunction with each other might not protect against all those arcs. But a lot of changes in 210.12. So we have to remember this. They have to be readily accessible, so that these AFCIs are going to be able to, they have the same testing requirements as a GFCI. So every month we're going to have to go up and make sure that they're operating properly. And those 6 choices are put into a list in 210.12, and they're calling the receptacle, they're calling it an outlet branch circuit device. And so we have a lot more opportunities, I guess, to provide protection for homeowners in the case that there is some arcing going on behind those walls. Hopefully this is going to enhance the safety, cut down on the fires that we've seen, and give us a chance, I guess, to fully protect that dwelling. My feeling is that in 2017 this will also be expanded, and we'll see maybe more parts of the house. So you're probably wondering what parts of the house are not protected by an AFCI. Well, we still don't have bathrooms are not in there, garages are not in there, unfinished basements are not in there. So there's a few areas of the house that are not protected by AFCIs, but we're getting close to making the whole house be AFCI protected. In Article 250, they've had some changes. So, of course, this is our grounding and bonding article, and this is one of our 8 choices for grounding electrode. And so in 250.52, it would show us those 8 choices. We would have our water pipe, building steel, and then our third choice would be this, which is going to be a concrete encased electrode. Typically, that's our rebar. And so what's happening in the construction field is when they come and pour the foundation, those people understand that the rebar is being used as one of our grounding electrodes. So now they've been stubbing it up. It's been common practice to stub it up, so we have access to that after they poured the slab. And so the National Electrical Code wanted to address that because it was common work practice out in the trade. And so they have, and what they wanted to make sure that we understood was this is just an extension from a concrete encased electrode. And so the electrode itself is all of the rebar that's joined together in that slab or foundation. It's all that rebar, and all we're going to have is an extension coming up somewhere that we can either CAD weld to or pressure connect to, however we want to make that connection. But all of our grounding electrodes at any facility have to be tied together. So if we're thinking about metal water pipe, building steel, and the rebar, we would bond all those together and then bring them back to the service with our grounding electrode conductor. So new terminology in the National Electrical Code about that. This is a major change for the people that do residential, because in 2011 we had a table that once we calculated the load for the service for a single-family dwelling, we could go to that table and we had our choices. It could be 100 amp, 125, 150, 175, 200, and that table went all the way up to 400 amps. Well, that table has been deleted completely now. So that table is gone, and what they have given us is in Annex D, they have given us an example of how to calculate our load now for a single-family dwelling. So once we go ahead and we go through Article 220 and we add in the square footage and the small appliance circuit, the laundry, the specific appliances that we might have, and we get our total load, we're now going to have to multiply that by 83%, and then we're going to have to go back to 310.15b16 and get the appropriate size conductor and match it up to one of those available choices we have that the manufacturer gives us for our panels. So that's going to be quite a bit of change, and what we really should probably do is look in Annex D, and the example is going to be D7. It shows us how to do that calculation, and that's going to be very important, because forever all we've ever done is gone to that table, sized up the right entrance, and then we'd go and install that. So that's a little bit of a major change. Before I do click to the next slide, I do just want to mention that they have addressed the charging stations for these electric vehicles also, and they're becoming more prevalent, and very important that the code book addresses this for safety reasons. The public are going to be plugging into these and charging their electric vehicles. So the circuit for that. It has to be a dedicated circuit. It has to be a separate branch circuit. It can have no other outlets on it. We'll start to see these charging stations in front of convenience stores. I've already seen them in front of many different types of small stores around the country. So understand that the code book has jumped on the charging station quite a bit also. Now I want to give you a little bit of an idea how we help a little bit with some of the changes in the code. So this here has been a slide that I've used for the past 6 years when I've done seminars, and it gives people a pictorial, and then we actually give them the proper terminology in the code. If we all applied that terminology correctly, there would be so much less confusion out in our trade. So I tell people in my classes all the time, I said, I need to know the color of the ground dead conductor. And I get everything all over the sun. Well, the ground dead conductor, of course, is going to be white, gray, 3 continuous white stripes, and this year in the 2014 code, they are allowing us to have 3 continuous gray stripes. So they changed that up a little bit, but I would also explain to everybody that sometimes the grounded conductor is also the neutral. So in this case, in this little diagram, you can see that it is bonded to the midpoint of that single-phase transformer, and in that case we can call it a neutral, but it's also a grounded conductor. So, and we can see that this just helps us a little bit with terminology. If you ever get an opportunity to attend our seminars, we actually help you navigate the code, and then we do quite a bit more on explanation about certain items. So the next few slides are just going to be a little bit of that, giving you an idea how we can maybe enhance the navigation process through the code, and also maybe expand your knowledge of the code in a more practical manner than how the code book actually gives us their language, which is more in the legal terms. So here is the table that we've had since the first code book I ever saw, which was in 1971, and back then it was titled 310.16. In 2011, they did change that to 310.15b16, and this slide is a very interactive slide, and you can see that we have some conditions on the side here. If the terminals are marked at 75 degrees Celsius, this is a nice little process that combines 110.14c along with 310.15b16 and gives you a chance to actually be able to be very confident in the size of the conductor that you need. So we have to understand that the terminals play a very important role in determining the size of our wire. If our terminals are marked at 75 degrees Celsius, then we can go ahead and use that column that is 75 degrees Celsius. That's no problem. But let's say that we had conductors that were THHN, which the slide is showing us. If we have THHN conductors, that would lead us over here to the 90 degrees Celsius column, but our terminals are only rated at 75, so we are only as strong as our weakest link. We would have to, even though THHN wire is being used on this circuit, we would have to come back to the 75 degrees Celsius column. We need 95 amps. We would have to come down to the number that's either 95 or the one closest to 95, and come over and see that we have a conductor size of 3 gauge. So these are the types of things that you might see in our seminars. Not just the changes, but something to help you really apply the code. If terminals were not marked at all in this application, we'd have to come all the way back to the 60 degrees Celsius column. And you know, we just hope that you know, you have the opportunity to really learn how this book is used and how to apply it for any of your applications that you might have. So we'll click a little bit again here. I wanted to give you an idea that American Trainco does, of course, provide training all over the world, really, and we do open public seminars. Monday and Tuesday of this week, I have been in Denver, and I conducted a seminar on the 2014 National Electrical Code, very well received. But we also do seminars at your facility, so we can go to your facility and take a look at your specific equipment and make that seminar so valuable for you, make it very specific to your needs. So that's happened a lot as I've been traveling around the country doing seminars. I might have to address maybe code violations. I might have to address safety concerns for people, and I'm actually training them on their own equipment. So just wanted to give you an idea that we do have two types of seminars. We conduct over 2,000 training courses every year, so more than 25 topics. We are all over the United States, so I'm sure we could be near you as quickly as we have to be. And you can see that we last year in 2012 we serviced over 20,000 students and gave those students a chance to rate all of our instructors, and you can see that they gave us a quite high score on that, so that was very nice in that case. And also want to give you an idea how you could contact any of us. Our website is AmericanTrainco.com. We not only do electrical training, we have mechanical training on there, and you know, here's our phone number. If you ever need, have a concern, email address right to sales, and sales will definitely take care of you. I also want to let you know that my personal email address is up here, robertjc@americantrainco.com. When this phone call concludes, we are going to have a few questions, so I'll be answering those questions. But if you didn't get a chance to get your question answered, because I see I have a stack of questions that have been emailed to me, you go ahead and just email me at that address, and I'll give you your answer as quickly as I can get off this phone call. I'll try to make it happen. So our phone number, our email address, and my personal email address, that's the contact info. And I do have some questions here, so that's going to be outstanding. I do want to let you know that you know, we should be taking the National Electrical Code very seriously. It is a document that has been around since 1881. The NFPA sponsored it starting in 1897. It's the oldest document that we have in the electrical industry, and let's get together and put some proposals in to try to make this a perfect document. So some of the questions that I did have come in, I'm going to speak to those right now. And one of the questions that came in is, were there any major changes in Article 250, which is grounding and bonding? And sure enough, there's been a new table introduced into Article 250. It's Table 250.102C, and that table is going to size up the grounded conductor for us. So our white, gray, or three continuous white or gray stripes is now going to be addressed in a new table. Previously, in all previous code cycles, we would have gone to 250.66 for that. That table is still going to be for our grounding electrode conductor, but now we certainly have a new table for the grounded conductor, 250.102C. Also in 250, it addresses the size of a DC grounding electrode conductor. So a table there for direct current grounding electrode conductors. Another question that did come in, when is this code going to be implemented? That is a outstanding question. I want to give you an idea that throughout the United States, this is implemented by the states themselves. So it's going to vary. I can tell you that 50% of these states will have this adopted by January 1st, 2015. Probably 20% of the states will have it adopted on January 1st, 2014, but some of the other states, they're going to take a look at the code. They will study it. They will take a look to see if maybe they want to amend the code. There are some states that, they might say, well, AFCIs, we're not ready for those yet, so we're going to amend it. And in our state, we're not going to require the installers to put AFCIs in. So it's a state-by-state process, and sometimes it even a local jurisdiction. So this is what normally will happen if you have a project that is has been started already. That project will be under the code that was in effect at the time the project was started. So whenever that permit was issued, that's the code that it will follow for that particular time. But each state is a little bit different, so you're going to have to check with your states. But over half of these states will have this adopted within a year. That's for sure. Another question came in, is changing from 600 volts to 1,000 volts affecting what manufacturers produce? And that is also another great question, and I've got to tell you it sure is, because all of our equipment has been UL listed at 600 volts. So now those manufacturers are going to have to go back to UL. They're going to have to have their equipment tested for that 1,000 volt rating. A lot of manufacturers knew this was coming down the road, so they've already had their equipment tested. I've seen some circuit breakers currently rated at 1,000 volts, so the manufacturers are on top of this, and they will definitely they'll definitely get get their equipment rated for that 1,000 volt higher rating. Had another question, what might have changed in Article 517, which is hospitals. Well, in that article, the Code Committee really wanted to align up with another NFPA document, which is NFPA 99 for healthcare facilities. So they have increased the number of receptacles that we need to install in those areas by quite a bit. So near the patient bed location, so within 6 feet of that patient bed, it went from 4 up to 8. If you're in the critical care unit, that went up from 6 to 14. And in the operating room, we used to have to put 12 receptacles in there. Now we have to put 36. So that whole requirement was just to align with another NFPA document. So there's been some changes in 517, that's for sure. Another question that came in, can you place electrical wires for equipment through a drop ceiling without a cover over the wires? Is it okay for lighting? And so here's what we have to understand, that ceiling tile, that has to be able to be removed. And so if our wire comes right down through the middle of that, that's not a legal listing of all that equipment. So if we're going to currently install any type of wire coming down through a drop ceiling, we're going to have to get over to the wall, and we're going to have to offset around the grid, the ceiling grid, and come down with an approved method. But to come right down through the middle of a ceiling tile, we would never be able to remove that ceiling tile, and so we have to make the ceiling tiles so that they are the flexibility to be able to remove them, and we're not allowed to just bring a wire straight down through a ceiling tile for lighting. The lighting should be either in the grid or supported independently of the grid, and the ceiling should not have to be removed at all because of that. Another question that came in, will GFCI for disposal and refrigerator be for equipment 35 milliamps rated or for people? That's a great question. So two different technologies here. So GFCIs, of course, are going to protect people, and this new change was in 210.8a, and section 210.8 is all about protection for people. So it's going to be at the 6 milliamp range. GFPEs that protect equipment, of course, that starts at 30 milliamps, but for these two appliances, disposal, refrigerator, and we can include dishwasher in that because dishwasher is brand new this year also, all of those are going to be at the 6 milliamp range. And so they're all going to be protection for people. And so that could be a little bit of a concern about reliability on some of those circuits, because we know that sometimes motors and water and the current flow is a challenge to keep the reliability of that circuit up and running all the time. But hopefully with the double insulation and the new trip level of the GFCI at 6 milliamps or more, that could help us a little bit with the reliability. Had another question come in. If I'm going to replace an existing panel in a dwelling unit, do I have to provide AFCI protection when that panel is changed out? And the answer to that is no, as long as we don't extend any of those branch circuits more than 20 feet. So if I'm putting the panel right back in the exact location where the old panel was, then AFCI protection is not required in that case. Another question that came in, have you heard anything from manufacturers about the possibility of producing panels with main circuit breakers capable of providing full AFCI protection? That has not been addressed yet. Manufacturers have not given us any indication yet that that's going to be the case. So when I conduct seminars, I always say to myself, wouldn't it be nice to have a main circuit breaker that gives you AFCI protection and GFCI protection? That would be outstanding. Take one breaker and protect the whole house. The manufacturers have not come up with anything like that yet, but we're hoping that maybe down the road it would be nice. But right now we're buying individual AFCIs, and what we have to think about this is that there's going to be two different technologies here on a lot of circuits. So there's going to be a lot of circuits that in the kitchen, let's say, that are going to be AFCI protected and GFCI protected. So we'll have that AFCI in the panel, and then we'll have a GFCI up on the kitchen counter, and we hope both of those technologies work in series with each other so that we will have some reliability on our electricity there. Are you aware of any manufacturers of combination AFCI, GFCI circuit breakers and or receptacles? Not at the moment. So at the moment, we're going to have to purchase an AFCI type device, whether it be the outlet branch circuit, the receptacle type, or and we're going to have to purchase the GFCI. So at the moment, there is nothing down the road that's going to give us that indication. Another question came in, does any aspect of the new code require me to update any existing facilities? In other words, are they grandfathered in? Okay, that's a great question, and the grandfather clause always comes up. In the 2002 version of the National Electrical Code, the grandfather clause was in Article 80. It was in the front of our book. In the 2014 edition, it's in one of the annexes, so it's still in the book. And basically, the grandfather clause addresses this, that if your building was built under the 1984 code, it can still stay that way as long as there's no imminent danger to the occupants. If there is imminent danger, then we would have to update. If you do an alteration, addition, or repair, you're going to have to bring it up to the new code. But there are some things that are not grandfathered, and so some of those items that are not grandfathered, if we do an extension of a branch circuit in an area that does have to have AFCI protection, then we are going to have to give it AFCI protection. If we change a receptacle in an area that needs AFCI protection, then we're going to have to also provide AFCI protection there. So there are a few places in the code that is not grandfathered, but I'm going to say that 98% of this book is grandfathered, so it basically applies only to new installations, so that shouldn't be, hopefully that's not too big of an issue. Another question that came in, was there anything new up in Article 406, which is about receptacles, and sure enough, if a receptacle is controlled by one of these energy management systems, which the new Article 750, if a receptacle is controlled by that, and it might be shut off because of this energy management system, it has to have a new symbol on the faceplate of that receptacle. It's a straight vertical line with about 3/4 of a circle. And so the straight vertical line will come straight down, and then that 3/4 of a circle will be right at the bottom of that straight line. And that's going to indicate to us that that receptacle might be shut off by our energy management control system that we have. So I hope today that we did give you a little bit of an update. It's hard to go through every major change in the time that we were allotted here, but if you do have any questions from now and in the future, just go ahead and email me, robertjc@americantrainco.com. I will definitely take care of those questions for you. I appreciate your time, and hopefully we have answered some of your questions and gave you some good information about some of the major changes in the 2014 National Electrical Code. Have a great day, and hope to see you sometime in the future.
Thank you all for your attention. This concludes today's conference call. All participants may now disconnect.